Hello and welcome to another tutorial on data analysis fundamentals brought to you by Earth Creations. Today we will look at parametric tests and an example of a parametric test, which is the T-dependent test. What are parametric tests? Parametric tests are statistical tests that make assumptions about the parameters of the population distribution from which the sample is drawn. This is often the assumption that the population distribution data is normally distributed. Parametric tests assume that sample data comes from a population that can be adequately modeled by a probability distribution that has a fixed set of parameters. Advantages of parametric tests. Parametric tests allow one to make generalizations from a sample to a population. Parametric tests do not require interval or ratio scaled data to be transformed into rank data. When to use parametric tests. Parametric tests are used only where a normal distribution is assumed. The most widely used parametric tests are t-test, ANOVA, linear regressions, and the Pearson rank correlation. The dependency test. The dependency test is also called the paired sample t-test, and it is the alternative of the non-parametric test called the Wilcoxon test. So, the dependent sample t-test is a statistical procedure used to determine whether the mean difference between two sets of observations is zero. It compares the means between two related groups on the same continuous dependent variable. In this case, we are talking about a test that compares the mean between two related groups on the same continuous variable. So we can have the same participants taking tested before and after a particular thing has been done to them. For example, in the Wilcoxon test, we demonstrated to see if a lesson taught to students had an impact on them by giving a test before the lesson was taught and giving a test after the lesson was taught, and then we compare the results of the two tests. So the main difference between this and what we saw in the Wilcoxon test is that in this case we are going to have continuous data, and of course the sample size is going to be larger than in non-parametric tests like the Wilcoxon test and the Mann-Whitney U test. When to use the dependent t-test. 1. The variables must be continuous. The observations are independent of one another. The data should be approximated or should be approximately normally distributed, and the data should not contain any outliers. A dependent t-test example. To demonstrate, let us assume that in a certain school, students are assessed to see whether a particular topic increases their understanding of a course. A test is given before and after the topic is taught. The students are scored from 0 to 10 in each of the tests, or the students are scored from 0 to 10 in each of the tests. The two samples, score before and score after, are analyzed using the dependent sample t-test. Let us see this in SPSS. So here we have our data, and we have the scores before the topic was taught and the scores after the topic was taught, and we see that our sample size is up to 51. There were 51 students in the class. And then when we go to the variable view, we will see that our data is measured at the scale level, which means the scores are, or the marks obtained by the students are actually scored from a score of 0 to a score of 10. We will have to check to see if our data is fit to be analyzed using the dependent sample t-test. We've already seen that the data is continuous and the two scores are independent of each other. And so now we will have to check for normality and for outliers. Do that for each of the samples. We will go to Analyze, come to Descriptive Statistics, come to Explore. Then for scores before tests, we will send it to the dependent list. We will come over to Statistics, check Outliers, click on Continue, come to Plots, check on Normality Plot with Test. We might also want to check the histogram. We check that, continue, then we click on OK. And then for our output, we will look at the Shapiro-Wilks test of normality. And here we see that the significance is the Shapiro-Wilks test of normality. We will see that the significance is 0.1, insignificant, which means our data is normally distributed. So if you have significance, it means your data is not normally distributed. In this case, we have 0.1, which is insignificant, begins to 95% confidence interval. So our data is normally distributed. And if you look at the histogram, we will see that it is approximately like a Gaussian curve, goes up and then it comes down. It's approximately the nature of a normal curve. And then we look at the box plot, we see that there are no outliers. To be able to check well, to know if there are outliers, if you do not know how to look in a box plot, you can visit our lesson on data cleaning and data wrangling. If there were outliers, we could see some dots or some stars out below here, and this box plot will not normally look like a typical box plot. So let us check for the second sample to see if it is normally distributed. In this case, we are taking the scores after the test. And of course, everything is okay. We come right down, we check Shapiro-Wilks test of normality, 0.069, which is greater than 0.05. So our data is approximately normally distributed. And then for the histogram, it still kind of follows a normal curve, the Gaussian curve. So there is that, and we come right down to our box plot. We will see that it is cool. There are no outliers. So our data is fit to be analyzed using the dependent student t-test. So to do that, we will come to Analyze, we come to Compare Means, we look for the paired samples t-test, and we take the first one, take the second. Then for options above 95% is there. Click on OK. Then we come right down to check our significance, and we'll see that it is 0.001. So we can see that there was a difference between the scores of the students before and after the topic was taught. And then we look, we have our mean here, we have the standard deviation, we have the standard error, which is small, indicating that our data closely represent our population. We have the 95% confidence interval, the lower and the upper limit. We have the t-value, which describes how far our observed data is from the null hypothesis. We have the degrees of freedom, and then we have our significance. So this is how we run the dependent sample t-test. Thank you for having followed through this video. Remember to hit the like button and subscribe to our channel. See you in the next lesson where we will talk on the independent sample t-test.